In this video, I'm doing an example of elasticity of demand that brings together all of the different ideas that we've been talking about in the previous two videos on the relationship between quantity demanded and price and revenue. So take a moment and read the example. First thing that we need to do is to obtain a formula for elasticity of demand. That's basically saying that it wants us to write this as a function. So we want to write it as a function. So first thing we need to do is find dq dp. Find the derivative of q with respect to p. So that's going to be negative 4p plus 33. Elasticity then is going to be the absolute value of negative 4p plus 33 all over 1 times p divided by q. But remember, q is our demand equation. So that would be negative 2p squared plus 33. Now, multiplying through the numerators, we get the absolute value of negative 4p squared plus 33p divided by negative 2p squared plus 33. Now, to get rid of the absolute value signs, as I demonstrated in another video, we can simply multiply through by a negative 1. It has the same effect as taking the absolute value, because multiplying by a negative 1 will change the sign from a negative to a positive. So to do that, let's just multiply the numerator through by a negative. And so that just changes these signs. That becomes a positive, that will become a negative. So we will have 4p squared minus 33p over, and I'm going to reverse these so the positive term is first. And there's my elasticity formula that answers part A. Part B asks us to compute the elasticity of demand if the price of a t-shirt is set at $10. So now that we have a formula, all we have to do to answer part B is plug in 10 for P. So elasticity is 4 times 10 squared minus 33 times 10 all over 33 minus negative 2 times 10 squared. And that ends up being equal to 0.419. So 0.419 is our elasticity. And then it asks us to interpret that. Well, the interpretation of this, because this is less than 1, that means this is inelastic. This is an inelastic situation, which means that for a given increase in price, the quantity demanded will decrease less than that. Inelastic, which also means that increasing price will increase revenue at this particular price point. The third part of this question says, how much should the physics club charge for the t-shirts in order to obtain the maximum daily revenue? So in a previous video, we learned that revenue is maximized when elasticity is equal to 1. When E is equal to 1, revenue is maximized. So let's take our elasticity formula, which was 4p squared minus 33p divided by 33 minus 2p squared and set it equal to 1, and then solve this for p. Solve for p. And this will give us the price where elasticity is equal to 1, which is where revenue is maximized. To do this, we will have to cross multiply 4p squared minus 33p equals 33 minus 2p squared. And now we have a quadratic, and so we need to set the quadratic equal to 0. So this will be 6p squared minus 33p minus 33 equals 0. And you can solve this using Desmos. P ends up, because it's a quadratic, you're going to have two answers, ends up having a negative answer, a negative 0.864, and it has a positive answer, which is 6.36 rounded to the nearest penny. Remember, this is a price, so this is either in terms of dollars. Now, this is the only answer we want to consider. We obviously do not want to consider a negative price. So we need to sell these t-shirts at $6.30 in order to maximize our revenue. And then finally, it says, what will this revenue be? So to find out what the revenue is actually going to be, we simply need to go to our revenue function once again. So revenue is price times quantity. So revenue is P, and Q, substitute in for Q, our demand equation, negative 2p squared plus 33p, which gives us a revenue function of negative 2p cubed plus 33p squared, and then evaluate that at 6.36 using Desmos. 6.36 squared, and that should end up being equal to $820.32. $820.32. So that would be our maximum revenue if we sell the t-shirts at $6.36. And that is an example of doing price elasticity of demand.